Hello, in this video we will examine how you can efficiently explore a table of values for a function. There are several reasons for exploring tables of values, but in this video we'll focus on using a table to approximate the roots of a function. So turn on your ClassWiz and let's set it up. We'll be using table mode in this video, so choose this mode with menu and number 9. You need to scroll down to find number 9, or you can just tap 9. To illustrate the techniques, we'll use a particular equation. You can see here a particular function which we're going to enter into the table mode. 3 subtract x squared subtract 3 to the power x. So we'll enter that in the normal way. 3 subtract, there's an x key up here on the right hand side of the ClassWiz. 3 subtract x squared and subtract 3 to the x, 3 to the power, and again we use the x key. So when we define the function, tap the equals key twice. We only have one function, so we only need to enter an f, not an f and a g. And we're going to use ClassWiz to find the roots of this function. So once we've got the function entered, we now need to enter a table of values, and we have to tell ClassWiz what the values are. A table can have no more than 30 entries on ClassWiz. When you don't have a good idea about the location of the roots, start with a wide table. So in this case we'll start with negative 14 for the lowest x values, negative 14, and tap the equals key. We'll go right through to 15 and tap the equals key, and we'll use steps of 1 and tap the equals key. This will give us 30 terms in the table, which is as many as we can have. To see the table, tap equals once more. And here's our table of values, and we can use the cursor to go to left and right. We can see when x is negative 14, it's a very large negative value. We can go right down many times and see some values are positive. Then we get some negative values again. So we can see the values every time in a larger font here at the bottom of the screen. Most of the values are negative. We're looking for values that are close to 0, and there seem to be some around about here. We can see that when x is negative 1, the value is positive. When x is 0, it's positive. But when x is 1, it's become negative. And likewise, a little bit further beyond here, the values changed here between negative and positive. So it seems from the table that there's a root somewhere here, and there's another root somewhere here. In other words, there seem to be roots of this function somewhere between negative 2 and negative 1, and somewhere between 0 and 1. The values of the function change between being negative and positive in those places. We'll now use ClassWiz to get a much better approximation to one of the roots by a process that is like zooming on a table. Let's look for the particular root that's this one here between 0 and 1. So firstly, tap the clear key, AC, to return to the function definition. And tap the equal sign twice, once to keep the same function, once to indicate that we don't need a second function, and now we can change the values of the table. To zoom in, we'll make a table of values between 0 and 1. So we'll make the smallest value 0, and the largest value 1, and make the step between the values 0.1. This is a small table with only 11 rows, but it will help us to see the roots. So tap equals to show the table again. We can see it's positive, the value is positive there. Going down here it's positive and less so. Now all of a sudden it's negative, and now it's negative after there. So the table allows us to see that there's a root of the function, that is a value when it's equal to 0, somewhere between 0.7 and 0.8. So let's repeat the process. of changing the table to get closer to that root. We pressed clear, equals and equals. We'll start with 0.7, go down to 0.8, and this time the table step will be even smaller. We know the first decimal digit is going to be 0.7, so we're going to change this time by 0.01 to produce a table that will go from 0.7 to 0.8. And here's our results. And you can again scroll here and can see that the values are positive but getting a bit less so. As we move down the table, we're looking for 0. Now it's jumped into being negative again. So we can get a closer approximation. The value where the function is equal to 0 is somewhere between 0.78 and 0.79. Here the value is positive, here the value is negative. You notice it's written in scientific notation in the table, and indeed down here it's a very small number. So we can repeat the process to see that there's a root somewhere between 0.78 and 0.79, and let's get closer to that. So we press the equals key, and a couple of times we start from 0.78 and end with 0.79 and make a small step this time of 0.001. And let's look at our table again. And we can see here as we look carefully at the results, they're changing in a slightly predictable way. Each time we go down the table, the result is changing by about 0.005. And we get down close to here, we're looking for the change. Here it is from positive to negative. That tells us that there's a root of the function somewhere between 0.788 and 0.789. So we'd like students to be looking at the values and thinking about the meaning of the values. We can keep this process of zooming continued for as long as we like and get a more precise approximation by 1 decimal place each time. Let's do this one more time to see how close the result gets in one more iteration. Between 0.788 and 0.789, the values change from positive to negative. So we will use those values in a new table. Tap clear again, in the same procedure, equals and equals, 0.788 and 0.789. And the change this time is 0.0001. Students have to think about these numbers to see how they change, and of course they're learning about the decimal number system as they're doing that. So the root is between 0.788 and 0.789. We know the first 3 decimal places are likely to be 0.788. So let's do it this one more time. Here we go. And the results, you can see, are now all in scientific notation because the numbers are very small. They're close to 0. And we're looking for where the value changes from being positive to being negative. Looks like it's about there. So the first 4 decimal digits of the root, the function, are 0.7885. And the next one is 0.7886 is too far. So this sort of process helps students to appreciate the idea of the root of a function very well. Students can use another table facility to get even closer than they have to this particular value. Maybe we'll do it just one last time and to show how this works. We can see 0.7885 is a little bit too small and 0.7886 is a little bit too large. We can change the value in the table directly. So I'm going to change this value. Highlighted the X value, 0.7886. I'm going to change it to 0.78855. which is a little bit different, and notice as soon as I do that, the value in the table has changed. And if I continue to, this is the one up here, the 0.78855. So we can change that value manually. This is still a little bit positive, so let's go a little bit further, 0.78856. And notice the result is still positive, 0.78857. And now the result has become negative. So we're getting closer and closer to the value, which is very close to 0.78857. So this is a manual process of what we sometimes call in mathematics guess, check and improve. Students are thinking about what they see, they're checking it with their ClassWiz, and they're improving on their guess. Now you might remember that, as you can see on the screen here, there were two roots of the function, one between 0 and 1, and we have a very good idea of what the value there is. We can find the value between -2 and -1 to get a good approximation to that root as well. How would we do that? We'll do that quickly this time so you can see the process. It's the same process as before. We'll start with the table between -2 and -1. -2 to -1. And for the first part of the table, use a small step, 0.1. And when we scroll down the table here, we can see the values are negative, and then they change to be positive when x is -1.6, -1.7 to -1.6. So we know there is a root between -1.7 and -1.6. So we can improve the table by clearing and go between -1.7 and -1.6. Again with the smaller step of 0.01. And now we can see there's a change. When x is -1.69, the result is negative, but when x is -1.68, the result is positive. So there's a root between -1.69 and -1.68. We could continue with clear, -1.69 and -1.68, and repeating the process, improving the decimal places by 1, and look for the change from negative to positive, which occurs there between -1.687 and -1.686. So there's a root between -1.687 and -1.686. A table is a powerful tool on ClassWiz for exploring values of functions, and this is one of the many uses to which that might be put. So this video has shown you a process of zooming in with a table to look for approximate roots of a function. You can use a similar process to find other values of interest, such as approximating a minimum or a maximum value of a function. You'll find that ClassWiz book, Learning Mathematics with ClassWiz, Module 3 contains information on how ClassWiz can be used to find roots or maximum or minimum values of functions, as well as detailed explanatory text which can be copied for students as well as teachers. The module includes some exercises to check efficient ClassWiz use, some examples of activities to suggest educationally valuable things to do, and some guidance for teachers. You can download this book freely from the Casio Worldwide Education website. Happy calculating!